Welcome back. This one's nasty. If you're making notes and you're at the bottom of the page, start a new page. What this question requires us to do is to dig into the whole bag of tricks for log functions. And as people that are very new to the land of logs, what we're about to do, what you're about to see, is not very friendly. The goal is to get x all by itself, and it's currently trapped in two different log functions. If we look at the previous example, what we did was we got the log function all by itself, and then we started using cancellation laws. But if we have two log functions that contain x, how are we supposed to get the log function all by itself? And the answer is, well, we have to make it one log function. We have to combine them into one log function. Combine logs into one log expression using what rule can we use? Well, the log of m plus the log of n is the log of m times n. We're going to use that rule. So we have, notice I have equals on that side. We have log base 5 of x plus 1 times x minus 3 equals 1. Okay, that's all we did was use a log property. And now we're going to exponentiate. Now we're going to exponentiate. Raise both sides as powers on a base of, now let's think about why we're doing this. We're doing this so that we can get access to a cancellation law. That's why we always log both sides or exponentiate both sides. It's that wonderful cancellation law that simplifies things that we really want access to. In order to use it, we need to match the base of the function that we're trying to cancel. So if we're trying to cancel an exponential, we log both sides using a log function that matches the base of the exponential. If we're trying to get rid of a log, we exponentiate both sides using a base that matches the base of the log. So we're going to use a base of 5. So we can match the base of the log and access the cancellation law. So 5 to the power of the left side is equal to 5 to the power of the right side. 5 to the power of log base 5 of x plus 1 times x minus 3 equals 5 to the power of 1. On the left side, we get a cancellation. That was the whole point. That was the goal. We want a cancellation law. On the right side, we just get 5 to the power of 1, which is 5. So x plus 1 times x minus 3 is equal to 5. The answer is not minus 1 and 3. That would be if we're setting those brackets equal to 0, but we're not setting them to 0, we're setting them equal to 5. So I'm going to expand next. I'm going to FOIL things out. I get x squared minus 3x plus x minus 3 is equal to 5. Then I'm going to collect like terms. Negative 3x plus positive 1x is negative 2x, so x squared minus 2x. And then I'm going to subtract 5 from both sides, so minus 8 equals 0. And now we're going to factor. I know we just unfactored it. I know we expanded it, but the point of expanding it was to bring the 5 in. Bring the 5 on the right hand side over so that we can set it equal to 0 and solve it the usual way that we solve when a quadratic is equal to 0. So x equals 0. mystery numbers that multiply to give -8 and add to give -2. So -4 and +2 will work. And then what happens next is it looks like we have two solutions. We have x is equal to 4 and x is equal to -2. And I'm going to circle the first one. This is a true solution. And then I'm going to put an x through this one. Not a solution. X equals -2 is not a solution. And here's why. If you plug it in, you get log base 5 of -2 plus 1 plus log base 5 of -2 minus 5, -3, sorry, is equal to 1. So log base 5 of -1 plus log base 5 of -5 is equal to 1. And you cannot take the log of a negative number. We violated the domain of the log function. The log function cannot accept numbers that are less than or equal to 0. It can only accept positive numbers. Okay, and then a few more types of examples. Working with log functions and exponential functions and rearranging and solving. And some of these mirror finance calculations. And some of them are kind of artificial and don't look like finance calculations at all. So for example, the first one is analogous to a finance calculation. You start with $100, you start with $10. You want to know how long it's going to take to reach $100 with an interest rate of 270%. So if it's 270% per year, how many years is it going to take? That's what this question is actually asking. But we don't need to know that, we just need to solve the math. Step 1, I want to isolate for the exponential function, the e plus 1 to the power of x. To do that, I'm going to divide both sides by 10. So 100 divided by 10 is equal to e plus 1 to the power of x. So 10 is equal to e plus 1 power of x. Now we come to a choice. We can take log any base that we want, including a log, the base of e plus 1. Rather than do that, I'm going to show you what is typically done. So if you were looking at a finance book, or if you were looking at a practice exam for this course, or looking at the textbook, what is typically done is if the base isn't nice, like a number or like including e, if the base is weird, like e plus 1, I know that's a number, but if it isn't compact, we'll just use ln. So I'll write down if the base is something like e plus 1 or square root of 3, etc., then log with base e. So ln both sides. So I'm going to take the ln of both sides, ln of the left side equals the ln of the right side. We're using ln because we want to untrap an x from the exponential function. Now I'm going to bring the x down in front using that log property. So ln 10 is equal to x times the ln of e plus 1. And we're almost done. We just have to divide both sides by the ln of e plus 1. Thus, x is equal to the ln of 10 divided by the ln of e plus 1. So a big picture strategy there. is we want to get the exponential function all by itself, which in this case is e plus 1 to the power of x. So we divide both sides by 10. Now, to get an x out of the exponent, we need logs. We want to log both sides. We chose ln because the base was really weird, e plus 1. If it was just, let's say, instead of e plus 1, if that was a 7, so 7 to the x, then we just do log base 7. We could do ln, but we would typically use ln 7. Okay, next example. We want to isolate for the log part of the expression first, so we're going to go through a sequence of moves to do that. 100, we're going to subtract 50 from both sides, equals 25 times the ln of 2x plus 1. So 50 is equal to 25 times the ln of 2x plus 1. Now we're going to divide both sides by 25, so we get 2 is equal to the ln of 2x plus 1. Now we have a log function inside which the x has been trapped. We want to exponentiate. With what base though? So to use the cancellation law, we want to cancel ln with a base of e, or log base e. We want to cancel a ln. So we're going to use base e. We're going to raise both sides as powers on the base of e. E to the power of the left side is equal to e to the power of the right side. E to the power of 2 is equal to e to the power of the ln of 2x plus 1. We have a cancellation law here. So we have e squared is equal to 2x plus 1, and we're not quite done yet. We still have to do some more work to get x all by itself. So I'm going to subtract 1 from both sides. E squared minus 1 is equal to 2x. Then divide both sides by 2. So x is equal to e squared minus 1, all divided by 2. Be cautious when you're working with expressions like this. That minus 1 is not up in the exponent, the 2. It's e squared and then that whole thing minus 1. So be careful where you put numbers. If it's not an exponent, don't put it in an exponent. Okay, next example. We already have the log function all by itself, so we can begin by exponentiating. Exponentiate with base e. We're matching the base of the log function. So e to the power of 2 is equal to e to the power of the other side. All that stuff. E to the 2 equals e to the ln of e to the 5x plus 3. I can cancel. And no, I can't cancel these two here at the beginning. And if that was your question, it's a good question, but that plus 3 prevents it from happening. If that plus 3 was up in the power with the 5x, then yes, I could do the cancellation, but it's not up in the power, it's down below, so I can't cancel those. But I can cancel these after I exponentiate. Okay, so now it says that e squared is equal to e to the 5x plus 3. Now we isolate for the exponential. Now it's the exponential with the x, since it's the x that we're trying to solve for. So I'm not going to try to isolate for e squared. If I had e squared plus something, I wouldn't try to get that all by itself. I want the e to the 5x all by itself. So I'm going to subtract 3 from both sides. E squared minus 3 is equal to e to the 5x. Next step is I'm going to log both sides. ln both sides, because I want to use the cancellation law. I'm using the same base of the log that as the base of the exponential. So yeah, I had to exponentiate and I have to log in the same question, and that can happen. Notice that the original function has a ln and an exponential in it, so it should be expected that I'll have to do both things. So ln of the left side equals ln of the right side. So the ln of e squared minus 3 is equal to the ln of e to the power of 5x. I can cancel the ln e to the 5x, the ln e on the right side, but I can't do it on the left side because of that minus 3. It's causing trouble again, but that's okay. So the ln of e squared minus 3 equals 5x, and we're done. We just divide both sides by 5. So x is equal to the ln of e squared minus 3 all divided by 5. Last question. Tricky. This one's tricky. You gotta think very carefully. I'm going to collect like terms, which is not a step we've had to worry about for exponential functions with like terms, but why not? We have to collect like terms for polynomials. Why not exponentials? So I'm going to subtract 2e to the 3x from both sides. 7e to the 3x minus 2e to the 3x equals, I'm going to subtract 4 from both sides, 14 minus 4. Now on the left side I have 7 of something minus 2 of the same thing. Like 7 times e to the 3x minus 2 times e to the 3x. So that'll be 5 of those things. 5 times e to the power of 3x equals 14 minus 4 is equal to 10. Now I'm going to divide both sides by 5. So e to the 3x equals 10 divided by 5, which is 2. And now I'm going to ln both sides. So ln of the left side is equal to ln of the right side. Ln of e to the 3x equals ln of 2. On the left side I have a cancellation. So 3x equals ln 2. And the last step, divide both sides by 3. So x is equal to ln of 2 all divided by 3. So fairly challenging. I have some worksheets that are connected to problems like this because the textbook is deficient in these types of problems with exponential functions and logs. I'll upload that along with the notes and the videos for this week. Anyway, see you next time.